We will start with section 5.2, in which we will review the hydrogen atom. It is on page 186, and then we will extend our discussion towards the hydrogenic atoms, like the atoms that are like hydrogen. And then we will calculate an approximated result for helium. We will approximate helium towards the hydrogenic atom. Now, as a review, you know that in hydrogen atom, we were having a positive nucleus, and means one proton at the center, and an electron is going around it. And for this system, we wrote the wave function NLN, where N is the principal quantum number, L the orbital quantum number, and the magnetic orbital quantum number. So for this system, we calculated the energies as well. And energies, we came to know that they only depend on N. So, for this system, we are having all the calculations. Now, we want to extend this hydrogen atom to some atoms which are like hydrogen, which we call the hydrogenic atom. I am considering the example of helium. Now, we know that inside helium, we are having two protons, and means not considering neutrons, but two protons and one electron in one orbit and another electron in the other orbit. So there are two protons and two electrons. Can we extend our discussion from here to here? Like, I consider this one combination means one proton with one electron, and then this proton with another electron. So it seems like we are having two hydrogen atoms together, and these two hydrogen atoms, when we will calculate the wave function of this system or the energy of this system, how much accurate we will be. So this one, that when I consider a proton and electron separately, and then proton and electron separately, then I will call this a hydrogenic atom. Or if I do consider, means I don't go to the nucleus, but just consider that it's for this one, Z is equal, the atomic number is equal to 1. And for this one, if in the same expressions I put means of the wave function and of the energy, I put Z equal to 2, and then I do calculate these things. So how much close I will be to the actual system of helium. Although there are some realities that we have here. The very first one, even if I ignore the nucleus and I just write Z equal to 2, then there are some other terms, and the other terms are that we are having the electron repulsion term here as well, which we don't have here. So we will have to include this term as well, and then the spin is an additional thing. Because here we were having the spin either up or down. And when we will come to a two-electron system, then there must be one spin up and another spin down. So this is just an approximation that we extend the hydrogen atom towards the higher elements, and that's why we call them as hydrogenic. They are just like, means we are approximating them like hydrogen atom. Now the approximation means it is very clear that our approximation will have many deficiencies, but we can approximate. So quantum mechanically it is very hard to calculate for the helium or lithium, or as we go on, it is very difficult to do the quantum mechanics, the derivations for them. But let's see that how much our approximations will go closer to the helium atom. So let's start from the review of hydrogen atom. We remember that in a hydrogen atom, we wrote the potential is minus E square over 4 pi epsilon naught and 1 over R. And the wave function that we wrote, sine NLM, this is equal, it's a function of r, theta and phi. We remember that there is no spin included here because spin is not a part of r, theta, r, phi. R, theta, phi only because it is with the same r, so it's only a function of theta and phi, which we think of, but it is not. So this is only the spatial wave function that we are calculating, and then we will add with this the spinors, the vectors which describe spin. So r, theta, phi, and this was equal to the radial part, which only depends on these two quantum numbers, and it's a function of r, and the spherical harmonics Ylm, a function of theta and phi. So this is the spatial wave function, and we know about our quantum numbers that the quantum number which is L is always less than n and can be equal to 0 or greater than 0, while m, we know that it is from minus L to plus L. So it is in between minus L and plus L, while the two values are included. So let me write for review that, let me just say it again. N is our principal quantum number, which the energy depends only on n, while n is the orbital quantum number, the angular momentum quantum number, and m is the magnetic orbital quantum number. So we derived the energy for hydrogen atom, and it was En equal to minus and the mass of electron by 2 h bar squared, then E squared over 4 pi epsilon naught whole squared, and this is 1 over n squared, and now this thing is equal, I can write that me 2h bar e 4 pi epsilon naught, this whole thing is a constant, it is not changing. So I can write this is E naught or E1 divided by n squared. So the n here, we know that it's a principal quantum number and it can have values 1, 2, 3. Energy depends only on n, while n will have many other values, like this will have in the form of L and M, it will have other values, but the energy for all other values of L and M will remain the same. And we discussed the ground state of hydrogen atom, and the ground state of hydrogen atom, we know that for the ground state N is equal to 1, N is equal to 0, and M is equal to 0. So the ground state E1 is equal to this value only, which is M minus ME over 2h bar square E square over 4 pi epsilon naught whole squared. And when I do calculate this value, this is minus 13.6 electron volt. And this is the ground state energy of hydrogen atom. This is the ground state energy. Now, what about the ground state wave function? The ground state wave function will be psi MLM. So we are having the values of N, of L, and of M, and this is equal to R NL. So this is 1, 0, and a function of R, and spherical harmonic will be Y00, 0, a function of theta and phi. And we know that this value is a constant value, which is 1 over 4 pi square root. So I can write that the ground state wave function, we have already derived this, so I'm just reviewing this in order to apply the things to the helium atom or any other approximation of hydrogenic atom. So this is psi 1, 0, 0. And now when we will extend our discussion towards a hydrogenic atom, means when we will have helium and now hydrogenic. If I want to convert this helium into a hydrogenic atom, so I will make this one as a helium ion, and it will be with 1 plus. I will remove 1 electron out of it. So in the nucleus, I will put Z equal to 2, and there will be 1 electron going around. So it will be hydrogenic atom, like Z here is 1, and here Z will be equal to 2. While there is 1 electron which is going around the nucleus, and here will also be 1 electron which will go around this nucleus. That's why I will call this a hydrogenic atom. So what will happen? The potential that I am using here is this one. Here is actually when I consider the Coulombic potential. You know the Coulombic potential V of R is 1 over 4 pi epsilon naught, and Q1, Q2 over R. Now Q1 here was the electronic charge, Q2 was the minus electronic charge, because 1 proton and 1 neutron. This is for proton and this is for electron. So we are having minus E square. Now when I consider this one as a hydrogenic atom, so for this one I will have Z equal to 2 times E. Means here now 2 protons, and means this is the charge. Q is equal to 2 times E, or I can write this Z times E. So Z is equal to 2 here. This is Q1, and Q2 will be equal to the electronic charge. So my equation will become that V of R is equal to minus Z E square divided by 4 pi epsilon naught, and I write R here with it. So now we will go towards some questions, and the first question is that what is the ground state energy, the ground state energy of hydrogen-like helium, of hydrogen-like, or I write hydrogenic helium, which is Z equals 2, and hydrogenic helium will be He plus, means we have removed one electron from it. And now the answer will be, I will write the energy equation, and the energy equation is that what will happen, here I will put, instead of E square, I will put Z E square, and that will be the energy. So En is equal to minus Me over 2 bar square, and this will become Z E square over 4 pi epsilon naught whole squared and 1 over N squared. And when I simplify this, then this is Z squared, and then the rest of the term is E1 over N squared. Now E1, I know that E1 is minus 13.6 electron volt. So this thing will be equal, En will be equal minus 13.6 electron volt into Z squared over N squared. Now I know that for hydrogenic helium, Z is equal to 2, and the ground state energy N is equal to 1. So this is 1 and this is 2 square 4, and if I multiply 4 with it, then the hydrogenic ground state energy will come 54.4 electron volt with a minus sign. So minus 54.4 electron volt comes out to be the energy of the ground state of helium ion, which we call the hydrogenic helium. Now, how accurate is this one? We will discuss this thing later on, that how accurate is this value, but we can approximate like this. Similarly, we can calculate the Bohr radius. Like we calculate for the hydrogen atom, which was 0.53 angstrom. So what will happen over here, that the Bohr radius A0 in the case of hydrogen was 4 pi epsilon naught h bar square by me square. Now we know that for the helium ion, it will become A, and the only replacement will be E square will be replaced by Z E square. So Z will come in here at this point. So it will be A0 over Z. And A0, we know that it was 0.53 angstrom. So for hydrogen atom in the ground state, it was 0.53 angstrom, and Z will come around 2, so it will be half of that radius which we were having for hydrogen atom. And similarly, the ground state wave function, we know that for hydrogen atom we were having psi 100, which is this one here, 1 over pi a cube e minus r over a. And here I will have to see here that this a is actually a naught in case of hydrogen atom. This is the Bohr radius, which is a naught, and here we are having a here, so a will be replaced by a naught, and I can write that it will be, I will have to replace a naught over there by z times a. So this thing will come like, I will have to write 1 over this. And another thing here, when I will put this thing, means here is a naught, and I will put now here the a naught over z here. So put for a naught over z, here a naught over z, so z will come up, it will become minus 2r over a. Similarly, that will go up here, and I will have psi 100 2 and square root 2, because it will come 8 will go up, I can write 8 is 2 and square root 2, and I'm a naught. Now I will write a naught because I have simplified this, and e to the power minus 2 r over a naught. Because first we will write this thing like pi a cubed and minus r over a, and then for a we will write, now a is a naught over 2, so we will put a naught over 2 and then we simplify and we will get this result, and this will give us the ground state of the hydrogenic helium, or helium ion in other words.